All right, good evening, everyone. So we have a great number of questions to solve today. Uh, Several questions from several topics on A-level mathematics. I really hope you can get the best understanding from this tutorial tonight. I would love you to be with your jotter so that you can follow through as we solve and ensure that you pay real attention. All right, I think we're going to be opening up with a question on binary operation. Let's see. Let's see how we're going to answer this particular question. Very simple, straightforward. I'm hoping everyone can actually relate to it. So we're given a question that said that the binary operation star is defined by the binary operation star is defined by A star B is equals to 2AB, where A and B are members of the set of rational numbers. So this is the question which I want you to pay real attention to. You are then told to answer this question, which said, what is the identity of the elements under this operation star? So this question is quite direct and very simple. This was actually a theory question in one of the related past question. And I really believe everyone here should be able to answer this question. Now, first of all, you need to understand that the most important part of any question on binary operation is the function on which the operation is defined on. So whenever you're given a question on binary operation, the first thing you want to look for is what is my binary operation defined on. Now I can see that I was told that this binary operation is defined on this operation. And the operation is A star B equals to 2AB, where A and B are members of the set of rational numbers. Now, the next thing to look at for is what is the question directed towards. This particular question is directed towards the identity of the element under the operation star. All right. Now, how do we go about solving the identity element? Now, I want you to understand that, as I often try to say, for the sake of every layman in the house, I always look at identity element more like a mirror, because when you have identity element with any other element, it mirrors the element back. So you're going to know an identity element if when you have another element with the identity element. Imagine you have, this is an element A with the identity element giving you the element back. So once you see an element that has this particular functionality, that's an identity element. So I always love to see an identity element in terms of like a mirror. And don't forget, it has a commutative property. What I mean by that is, if you have A star E Of course, you could also ask what will be the resultant of E star A. Well, it has a commutative property, meaning that A star E is the same thing as E star A, and it will also give you your elements back. All right. Now, with this, establishing this rule of thumb, we have to then go back. For us to be able to find our identity element, we have to go back. I told you already, the most important part of your binary operation question is where the binary operation is defined on. So looking at what we have here, I have it being defined on A star B being equals to 2AB. Always understand that the use of the word A and B here represent first and second element. Don't have to be rigid on that it has to be A or it has to be B. All this means and implies is that when you bring in an element, the first element with the second element, this is how it flows. It will be the 2 times the first element times the second element. It's just that way. So A and B are all dummies. It's more like a placeholder. So in the case where we're trying to find for A star E now, because this is the property for my identity element, I'm trying to find A star E right now. So obviously I have to revert back to my operation where my operation is defined on. So A star E obviously will be equals to, based on this operation, it will be equals to 2AE. In this case, now you can see that the second element here is E. All right. Now, with what I defined here, I was told that whenever I have A star E, that means an element star the identity element, I must get the element back. So that means this A star E, which was now based on our operation is 2AE, must give me A back. All right. Looking at this, I can see that 2AE is equals to A. Don't forget, the question said we should find the identity of the element under star. So my E is my value of interest. So if I go on to divide both sides by A, I would have 2E equals to A. Sorry, 2E equals to 1. Dividing both sides by A, and from here my E is equals to 1 over 2. Now, if you look at this, I've been able to decode that the value of my identity element is 1 over 2. Now, this is perfect, but I would love you to go on to verify your answer. And the way to verify your answer is to make use of A star E and E star A. So now let's see if this actually is valid. This is what I got as my identity element. So I can go on to validate this answer, to verify this answer by trying to confirm if it works. So let's go on to find A star 1 over 2. Of course, don't forget, the definition of my identity element stated that A star, whatever was the identity element, must give me A back. That means if this was truly the identity element, when I have A star, the identity element, I must get A back. So this is the condition I want to try. I want to test for this. I want to test for this particular one. And I would also go on to test for the other part that said, if I go on to find a commutative aspect of it, that means E star A, E here being 1 over 2. So I'll go on to find if 1 over 2 star A will also give me A back. Now, if these two conditions are fulfilled, then I will now finalize my conclusion that my identity element is 1 over 2. So let's quickly try and do that quickly. How do you find A star 1 over 2? Of course, I told you anything you want to do on that identity element, under your binary operation, rather, always revert back to the operation on which your binary operation was defined on. So I want to find A star 1 over 2. I go on to make use of my binary, my binary operation is defined on. That means I'll be having 2. Of course, A is the first element, and I have A. Then my second element now is 1 over 2. That means I'll be having times 1 over 2, because that's what I have. 2 first times first element times second element. First element here is A, second element is 1 over 2. So this will be giving me, of course, 2 cancels 2. I'll be having a value of A. All right, this has been confirmed for the very first. I can see that this is truly an identity element, because when I did an element times that 1/2, it gave me the element back. So that confirms that this is in line with being an identity element. Let me go on to confirm if the commutative aspect of it will also give me the same. So that will be 1/2 star A. Let's see if this will also give me A. Fixing this back into our binary operations function, of course, this will be 2 times the first element now was 1/2. That'll be times 1/2 times my second element is A times A. Of course, 2 cancels 2. I get the value of A. You can see directly now that this is perfectly confirmed that 1/2 can now be defined as the identity element under this particular binary operation. So that is it, guys. We are done with this question. We can go on to the next one. The next question, let's delve quickly into a polynomial question, and let's see how you guys are able to cope with that. Let's do polynomials very quickly. By the way, I suggest we have probably tomorrow a polynomial class. I know I talked about binary operation, but I'm thinking you guys may gain more from having a polynomial class. I don't know. You can have a debate on it and let me know what you feel. Binary operation or polynomials, which would you prefer? But this one will be by 6 o'clock as usual. Of course, today we've been able to exhaust our the aspects of sequences and series. So we're done with sequence and series already. So we'll be going on to any other topic of your choice. If you want binary operation, you let me know. If you want polynomials, you let me know. All right. Now, this next question said you should formulate a polynomial whose quotient and remainder, when divided by, look at the question here, formulate a polynomial whose quotient and remainder when divided, this is a direct question, a direct past question, when divided by x plus 1, we have x squared plus 3x minus 2 and minus 3 respectively. All right, study this question carefully and let's see how you are able to solve this. Now, you're told to formulate a polynomial of whom the quotient of this polynomial and the remainder when divided by x plus 1. Now, you need to be able to get out all the variables in this question and don't get confused because... All right, can you still hear me, please? Please, I want you to indicate if you can still hear me. Sorry for that little glitch. Okay, all right. So I want you to, as I was saying, when you're given a particular question, always, I understand mathematics is mathematics, but many of the times you need to always understand English also in order for you to be able to solve mathematics. Now, you're told to formulate a polynomial whose quotient and remainder. Now, when divided by x plus 1, this is a separate thing on its own. So telling you that this is the divisor here, this is what you're using to divide. This is what you're using to divide. But this particular question, when they say whose quotient and remainder, meaning this is the quotient, this is the remainder. So this here is the quotient, and this here is the remainder. You need to know how to interpret that. Now, you're told to formulate a polynomial whose quotient and remainder is this. Now, I may not be able to take you through the entire basis of polynomials, because of course I told you already we can have a special class on this. But of course, if you want that, if you want polynomials, we can have it tomorrow. So let me just quickly, because normally this is what I'm going to write for you. But a lot of people will question how I'm able to bring out this particular equation. But probably I will give you a background knowledge of it later or now. Let's see. This formula I'm writing right here is the key to solving this question. This formula I have right here is key to solving this question. Now, look at what I wrote here. I wrote, this is the polynomial, obviously. P of x here represents in the polynomial. D with an argument of x here represents the divisor. That means what exactly are you trying to use to divide this polynomial? This is it right here, the divisor. And the qx here represents the quotient. And the how here represents the remainder. The remainder. Now, as I said already, this formula, it's not rocket science. It's very, I could explain everything about it. I probably would revert back to the polynomial class for you to understand this, or let me know if you want me to explain right now. Right? Could I get your feedback on that? I could explain how this formula came to pass. It's quite very simple and easy to understand. But if you all understand it and you want me to just go on to use it, I'll use it. But I'm sure that a lot of viewers will be asking, how did you get this formula? Because using this directly gives you the answer of this polynomial. Because obviously now you have your quotient. You have your quotient, which is this. You have your remainder, which is this. And you have your divisor, which is this. So it's all complete. So, and I'm told to formulate a polynomial of which I have my quotient, I have my divisor, I have my remainder. All these things are given in the question already. So applying this formula, I get a perfect answer. I'll get a perfect answer. So you know what I'm going to do? I'm going to try and use it, and then probably if time permits us, I will explain. So I will use this formula now, and then you will see how we're going to get this answer in probably like 2 minutes. All right. I know my d of x. My d of x here is my divisor as x plus 1. I know my quotient qx to be what? X squared plus 3x minus 2. I know my remainder rx. The reason why you have rx there, even though some of you may say we do not have any x value here, but I want you to understand that sometimes the remainder may also have an argument of x. All right, the r of x here is minus 3. So putting this in, you can attempt it on your own while I'm solving mine also. Try and fix all this in and you will see what we're going to get. So my polynomial of x here will give me, this will be, of course, x plus 1 multiplied by x squared plus 3x minus 2, then plus minus 3. Let's go on and open this. We have x times x squared, we have x cubed plus 3x squared minus 2x, of course, plus x squared plus 3x minus 2. And we have a last plus minus 3. Of course, I'm sure you can flow with that. Now, I want to group everything that has x cubed. I can see only one has x cubed. So this is just x cubed here. Then I go on to have my x squared. I can see 3x squared here and x squared here. 3x squared plus x squared will give me my value of 4x squared. I'm sure everybody can relate to that. And I can see minus 2x here, and I can see plus 3x here. Minus 2x plus 3x gives me a value of x, because you are having 3, you are having plus x. And then I can see the last values here, minus 2 and minus 3, will give me my value of minus 5. And that is it. This is the polynomial they were asking me to find. Now, I told you already, it's an easy peasy way of getting a quick answer to any question, applying this formula. All right. I think let's just talk more on this in our major class on polynomial because of time. I would love us to solve a couple of questions. Of course, we can go on to talk about it probably at the end of this class. Now, let's quickly solve a particular question on, let's solve a question on binomial expansion. All right. I'm sure you guys could flow with this again. If you have an issue with how we got that formula, don't worry. When we have a full class on polynomial, I'll be explaining every detail of it. It's quite very simple and straightforward. Everybody can understand it. So now you're given a question and you're told to obtain the coefficient of, AB raised to power 4 in the expansion of a plus b over 2 all raised to the power of a. Don't worry, I'm going to write the question for you right now. So let's try and see how to solve this next question. Okay. Obtaining the coefficient of a term in a binary operation is quite simple, and it comes out a whole lot. So this is the question. We are told to obtain the coefficient. This is a direct past question of AB raised to the power of 4 in the expansion of now this is the expansion a plus b over 2 raised to the power of 8. Right? So this is the question we're told to solve. I would love you to make your trial on this very quickly. How do you go about this? By now, I expect this is a question you should solve in less than 2 minutes or thereabout. Of course, I don't expect anyone that has been following these classes to go on to be trying to expand all this, because that would be a very tedious and ineffective way of solving this question. If you decide to try and expand all this and you want to now go on to look for which one has the term AB raised to power 4, that is a process that will give you an answer, but it will not be efficient, of course, when you are in an exam hall, because you'll be having a limited amount of time. So what you want to always do when you have a question like this, as I told you before, is for you to act like you wanted to open this particular expansion, but you would not have any k value. Don't forget, my k value represents my incremental value. So I wouldn't put an incremental value. All I'm going to do is to just act like I was going to open it. Of course, if I was going to open this, I was going to say 8 combination k, and the first term a, which was a, raised to the power 8 minus k, and then the second term b over 2 raised to the power k. So that's the first thing I'm going to do. I'm going to act like I was just attempting to open this question, the particular question. Now, put in mind that whenever you are asked to find the coefficient of anything, this is your guiding term. So this is what you are moving towards. So you'll be doing everything to try and see AB raised to the power 4. Now, I want to split this particular b over 2 because I can see b is having over 2, and I don't like that because it will prevent me from being able to see AB raised to the power 4. So I want to do something like this. So I will have a raised to the power 8 minus k. That's still okay. Then for this one, I'll be splitting it as 1 over 2 times b raised to the power k. I'm sure nobody believes I've cheated or done anything wrong. All I just did was split this fraction into 2. Now I can go on now to have 8 combination k, a raised to the power 8 minus k. Then I can have 1 over 2 raised to the power k, then b raised to the power k. Now you can see how I've successfully splitted this in such a way that I don't have to deal with that fraction close by anymore, because my interest is to see AB raised to power 4. That's where I'm moving towards. All right, now let me try and bring A and B close to each other. Now I can have 8 combination K. Let me bring 1 over 2 here. Just rearranging the places where I'm placing them because for the sake of clarity. So this is 8 minus K, then B raised to power K. All right, I've been able to bring A and B close to each other. Now, don't forget, this is what I'm moving towards. So I'm looking for, of course, I'm sure nobody disagrees that I can write AB raised to power 4 as A raised to power 4 and B raised to power 4. I'm sure that you understand that that's what this implies. All right. So I want to look for what the term for K will be that will give me this particular value, where I'll be having A raised to power 4 and B raised to power 4. I want to ask the audience now, what do you think my K is supposed to be that will make this particular place look like this? My K has to be something. What value of K will make me to have the value of A raised to power 4 and B raised to power 4? Of course, it goes without saying that if I place my K as 4, I'll be having, let's try it. Let's see if it works. If I place my K as 4, I'll be having A raised to power 8 minus 4, then B raised to power 4. Let's try and see this. A raised to power 8 minus 4 is 4, then B raised to power 4. You can see already that this, when K equals to 4, when K equals to 4, I will be having AB raised to power 4. So all I need to do in order to obtain the coefficient of AB raised to power 4 in this particular expansion is to just go on and fix my value of K as 4. So if I fix my value of K as 4, I'll be having 8 combination 4, 1 over 2 raised to power 4. You don't ignore any of the terms. Then you have A raised to power 8 minus 4, then B raised to power 4. So you then go on to solve this. What is 8 combination 4? 8 combination 4 will give you a value of 70. So you'll be having 70 times, this would be 1 over what? 2 raised to power 4. Of course, you know this would be 1 raised to power 4, which is 1, and 2 raised to power 4, which is what? 16. So you'll be having 70 over 16, then times A raised to power 4, B raised to power 4. All right. What is 70 over 16? 70 over 16, when you break that down, will give you a value of 35 over 8. A raised to power 4, B raised to power 4. So this is the term that will give me my value of 35 over 8, A raised to power 4, B raised to power 4. Now the question was find the coefficient of A raised to power of A, B raised to power 4. The answer to that is obviously going to be 35 over 8. So the coefficient there is 35 over 8. So this is how you solve questions very easily without wasting so much of your time in an exam. Or understanding the logics to all these topics will help you to economize your time in any exam hall. All right. So we want to go on now to solve a question on matrix. We want to solve a quick question on matrices. And let's see how we're going to be able to get this settled. All right. By the way, those of you joining us for this class, if you are yet to give a thumbs up to this particular feed, please do that as soon as you can. So I'll be writing the next question we'll be solving right in front of us. The question went on to say, obtain the value of x and y in this particular matrix equation. We have to obtain the value of x and y. This particular question will test your ability to multiply two matrices together, and will also test your ability or your knowledge on equality of matrices. So these all are direct questions from past questions. Nothing changing, is just a direct question. That to obtain the values of x and y in the matrix equation that will be given now, now this is the matrix equation we have right here. We have 2, we have x, we have y, we have -3. Then we have a sign that shows you are multiplying here. The 1, 3, 2, 5 as this other matrix. And you are told that this was equals to 6, 4, 16, 15. All right. Now this is the question that we have right in front of us. That to obtain the value of x and y in this matrix. This is a past question. I'm sure majority of you should be able to solve this. Now this will test your ability to multiply two matrices together. All right. So let's go on to try and get the value of x and y in this particular matrix. So first of all, you need to understand that when you're given a question like this, you need to understand that when they told you, this is not a question asking you if this was equals to this. The question told you already that the left-hand side is equals to the right-hand side. And if you remember our definitions of matrices when we're dealing with equality of a matrix, we said that if two matrices are equal, that means if matrix A, if this was matrix A, let's say this was matrix A, and we have another matrix B. Our definitions of matrix multiplication is if two matrices, if A is equals to B, if A is equals to B, this must happen. This and only this must happen. Number one, in this case, A must be equals to E. Matrix A must be equals to, the element A must be equals to element E. Also, the element B must be equals to the element F in the other one. Then the element C here must be equals to the element G. And the element D must be equals to the element H. If these rules are not fulfilled in any form, let's say for instance, 1, 2, 3 was fulfilled, but this wasn't fulfilled. If this happens, you cannot define those two matrices as being equal. It is important and compulsory that if two matrices are said to be equal, then each element in row 1 here must be the same in row 1 here. So I believe we all understand that. So let's go on then to try and use that knowledge to solve the question in front of us. All right. Now let's see what we're going to do here. The first thing, the first test of our knowledge here is, do we know how to multiply two matrices together? Of course, I believe we all should. Before we decide to multiply any matrix, you need to be sure that these matrices we can multiply them together. So we have a 2 by 2 matrix here. We have a 2 by 2 matrix here. For us to be able to multiply two matrices together, the column of the first matrix must be equal to the row of the second matrix. In this case, 2 is here, 2 is here. That means this can go, and our result will be obviously the leftover here and the leftover here. So we're going to get a 2 by 2 matrix. All right. Now let's move on with multiplying this matrix, since we have been able to confirm that this matrix can be multiplied together. How do we multiply this matrix together? We have our result as a 2 by 2 matrix. The way I try to give students this knowledge, of course, it doesn't have to be this way, but just for the sake of a step-by-step process, what I will ask you to always do is to try to bring out a dummy of what this 2 by 2 matrix would look like. So that means I can go on to say a 2 by 2 matrix obviously looks like this. All right. And of course, you need to know how to define each of these places. Don't forget the row is the horizontal, the column is the vertical. So this is row 1. This obviously, this first place here is row 1, column 1. This is row 1, column 2. All right, I'm sure we all agree with that. So the way to solve this without making mistakes is, guys, you need to learn to always be error-free when solving questions. I'm sure many of you look at this question as being very simple, but if you're not careful enough, you could make a terrible mistake, especially when you're trying to be in haste. Now, this is row 2, column 1. This is row 2, column 2. So what I want to do is to get my result for row 1, column 1. And how do I get that? You will pick row 1 on the first matrix and meet it with column 1 of the second matrix. For this place, row 2, column 2, I'll go to row 2 in the first matrix. This is row 2 here, and I will meet it with column 2 of the second matrix. That's the best way of achieving your answer without making any mistake. So let's try and do that quickly. For me to do this, this is row 1, column 1. This is row 1 here. I'm meeting row 1 here with column 1 here. That will be 2 times 1 plus x times 2. 2 times 1, that will be 2, plus, what is x times 2? That will be 2x. That's the very first answer for my new matrix. Now, for this second place, this row 1, column 2, I will pick row 1 on the first matrix, meet it with column 2 of the second matrix. In this case, I have row 1 with column 2. That will be 2 times 3. That will be 6 plus x times 5, 5x. All right. For us to get the other side of this, that's row 2, column 1. I'll take out row 2 here with column 1 here. That will be y times 1. That will be y plus minus 3 times 2. That will be minus 6. All right. And for the last but not the least here, we have row 2, column 2. That will be row 2 times column 2 here. That will be y times 3. That will be 3y. Then minus 2 times 5. That will be minus 15. All right. So this is my result when I multiply these two matrices together. Now, the next part of this whole thing now was that I was told that the result of this gave me is equals to this other matrix I have here. Now, if they told you already that this matrix and these two matrices are equal, with what I explained earlier, that means row 1, column 1 here must be the same thing as row 1, column 1 here, if they are truly equal. If it wasn't equal, if it was equal, then they must be the same. That means for this, and since not just for it to be valid, since this is equals, that means 2 plus 2x must be equals to 6. The same thing goes that 6 plus 5x must be equals to 16. And then y minus 6 must be equals to 4. And then 3y minus 15 must be equals to 15. This must happen. Now, let's go on to see how we're going to, we can use any of them to get, don't forget, we are to obtain the value of x and y. So I can use any of these particular 4 equations to get my value of x or y and y. So I can, let me use the first one. 2 plus 2x is equals to 6. Obviously, 2x is equals to 6 minus 2. 2x equals to 4. My x equals to 2. All right. That's perfect. I've gotten my x to be 2. Now, let me go on to try and obtain the other one here. That's for y. Y minus 6. Let me use this particular one to get my y. Y minus 6 equals to 4. My y here equals to 4 plus 6. My y here equals to 10. So my y is equals to 10. My x is equals to 2. Now, you can go on to confirm this for every other one. If you use this particular one, you must still get the same answer. So if you don't get the same answer, that means you made an error. So we can go on to examine that if you will. 6 plus 5x must be equals to 16. That means if 6 plus 5x equals to 16, that means 5x equals to 16 minus 6. That means 5x equals to 10. x equals to 2. Obviously, it gives us the same answer. If you use for 3y minus 15 equals to 15, 3y equals to 30, that's 15 plus 15, y here equals to 30 over 3, which is 10. So this is perfectly done. That means I can conclude now that my x is 2 and my y is 10. All right, so that will be all for this matrix question. We are done with that. Let's go on to the next question. Let's do a polynomial question quickly. And this is a verbatim question from the past question. I believe from all these tutorials, you should become very versatile in all these topics in such a way that you will be so used to them that there will be no aspect of it that you won't be able to solve. And that's the pathway towards achieving a grand style A. At one point, I expect that all these things are so familiar that you don't have to even blink before you answer them. That's the goal to solving questions persistently. That's the pathway to being excellent in mathematics. Practice is what makes perfect right here. All right, so let's try and see what this question is going to result in. We're told to deduce, this is a direct past question. We're told to deduce the quotient. I think I need to explain the meaning of the word quotient for those that are probably not used to that word. Of course, when we talk more on polynomials, I would still shed more light on that. And that's why I told you have to understand the use of all these terminologies. They are also a part of examination. Because if you don't know what a quotient is, then there is no way to actually start this question. Now, a way of asking this question without using the word quotient still exists. But in order to ensure that they also examine your knowledge of these terminologies, the use of the word quotient was placed there. So a way of explaining this without using the word quotient would be that what's your answer when you divide this by this? So what's your answer? What are you going to get? So in the case, for those of you that want to understand it better, if I say 10 divided by 5, of course, my answer there is 2. So 2 here is representing the quotient. If I say 10 divided by 3, the answer here is 3 remainder 1. 3 here is the quotient because 3 is your answer. This is the remainder. 1 is the remainder. And on and on and on. If I say 20 divided by 4, what do I get here? 5. Okay, let me use another value that will not be complete. Let's say 20 divided by 3. This will be 6 remainder 2. So 6 here is the quotient. So that's what you are asked to find now. You're asked to find a quotient when you divide this particular polynomial with this polynomial. Now, I need you to understand one thing here. Many of you will look at this question and it looks very direct, but there's something you can, if you stay on it very much, you will understand that there's something missing in this particular one. I'm sure you understand that equations are expressions are always written in terms of highest power to the lowest power. Now you can see we have 2x cubed here. Then the next power was 3x raised to power 1. Obviously, they didn't write 1 here, but you know this is raised to power 1. You notice that there is no x squared here. And then you have a constant term. In this particular case, you have x squared plus x minus 2. Now, let me say one thing. Before you decide to make divisions of polynomials, there's one condition that must be fulfilled before you can decide to divide a polynomial with another polynomial. The polynomial you are trying to divide something by must have an higher power, the highest power than the other one. So if this one right here is x raised to power 4, let's say here we have x raised to power 4, it will not be possible for us to decide to make this expression work. So we won't be able to divide this by this. So it works perfectly now because we have x squared and the highest power here is x cubed. So this obviously has a greater power than this. That's why it balances up and we can decide to make this division. Now, but the other thing I want you to always do when you are given a question like this, of which a polynomial is missing, I see somebody writing a very wrong answer. Again, that's the reason why you have, okay, the person has retracted the answer. And this is the reason why you you have to pay attention so that if you were in an exam or you will not have the benefit of getting a solution. And that's why you have to prepare very well so that you don't make mistakes. Many a times students come out of the exam or feeling they've gotten the answer, but they've made a mistake somewhere. So let me give you something that would give you the right direction to this. The first thing I want you to do is this polynomial you are trying to divide, always make sure if they have the same power, that's still going to be possible in some cases. All right. Now, always make sure that in this case now you're going to change this first polynomial to this. That means I'm going to look at what I'm going to do here. 0x squared plus 3x plus 1. Of course, this is what I'm going to call my polynomial. Of course, and this is the divisor. What I have here now, x squared plus x minus 2. This will be the divisor. All right. So you can see what I did right now. I went on to put a dummy, a placeholder, just like a placeholder. I'm adding 0x2 as a placeholder. Of course, you know that 0x squared doesn't add anything to this particular expression. So I'm not changing the question. I'm just making it much more solvable. All right. Now, what are we going to do next? I think I'll be needing a larger space for this. So let me try and, of course, you have seen what I did now. So let me try and create space so that we can make the division of this. I'll be using the tree situation. That means using the division tree. And I'm sure some of you can do it. So let's see how we're going to solve this. The first thing to do is to draw out the tree. And right here, you have the polynomial you're trying to divide. And right here, you have the divisor. All right. So we have 2x cubed. Don't forget, I'm placing a placeholder of 0x squared plus 3x plus 1. And I'll be having x squared plus x minus 2. So what you're going to divide will be here. And what you're using to divide will be outside here. All right. And this is where you're going to be placing what we call the quotient. That's the quotient. This is where, so whatever we are writing here will be our quotient value. This right here is for our quotient. And at the bottom of this tree, if there's anything left, that's where our remainder will be. All right. Now let's go on and try and solve this. What do we do first? When we want to solve this, you start with this x squared is what you're going to be using majorly. So you're going to ask yourself, x squared goes in 2x cubed. How many times? All right. So x squared goes in 2x cubed. You pick the first to meet the first. X squared goes in 2x cubed. I'm sure you agree with me that that is 2x squared. Now, I prefer you write it on top of the, write it here majorly. So we'll be having 2x as that value. X squared goes in 2x cubed 2x times. That means, of course, you can notice that if you do 2x times x squared, you'll be getting 2x cubed. So after you have done this first thing, asking yourself x squared goes in 2x cubed, then you got this answer as 2x. Then you use this 2x now to multiply all the values here. So 2x multiplied by x squared, that will give us a value of 2x cubed. Then you go on to say 2x multiplied by x, that will give me a value of what? 2x squared. Then 2x multiplied by minus 2, that will give me a value of minus 4x. All right. So after I'm done with that multiplication of every of the terms here, then I can go on to make my subtraction. Subtraction it is. So how do I subtract this? 2x cubed minus 2x cubed. Of course, that goes away. That's 0. I don't have to write that. Then the next one we have 0x squared minus 2x squared. Of course, what do I get there? I get the value of minus 2x squared. All right. And then we have 3x minus 4x. Please always patiently try and do all these things so that you don't get the wrong answer. That will give me plus 7x And obviously, I can decide to bring this down here. That will be 1 minus 0, that's 1. All right. Now, the next thing to do now, you have done for the first layer. You then go on to do the same thing with this next layer. So you'll be having x squared goes in minus 2x squared now. That's the way you just ask yourself. Use this first term, ask it for the first term, and then the answer you get, write it on top here. Then use this particular answer to eat all these terms and write the answer here. Very simple and straightforward. So we have x squared goes in minus 2x squared. That will be what? Minus 2, obviously. This will be minus 2. Then go on to have minus 2 multiplied by x squared. That will be what? Minus 2x squared. Minus 2 multiplied by x, that will be what? Minus 2x. Then minus 2 multiplied by minus 2, we have what? Plus 4. All right? So I can go on to make the same process, and that's subtraction. So when we go on to say minus 2x minus 2x squared, minus 2x squared minus 2x squared, that goes away, that becomes 0. So we'll go on to say 7x minus 2x. That will be 9x. That will be 7x plus 2x. That will be 9x. And then we then have 1 minus 4. That will be minus 3. 1 minus 4. That will be 1 minus 4. That will be minus 3. Now, the next thing to ask yourself is, you don't know, some of you may be wondering, what do I do next? Do I go on to say x squared goes in 9x? Of course, that's not possible because I told this power now is lesser than this. So you can't say x squared 9x divided by x squared. That's not going to work. So this is where you're going to stop this particular division, and you end it. You have to end this particular division at this point. X squared cannot go in 9x. You can't do that in this particular process. So this is where you're going to end it. So you're going to define this obviously as a quotient. This is the remainder. And of course, this question did not care about me getting the remainder. It only cared about me getting the quotient, which is, my answer is what? 2x minus 2. So the value of my quotient, according to this question, is 2x minus 2. All right. So this is nice. Let's try and solve one more question, and we can call it a night. Oh, rather no, we have a particular, I will still say something after this next question. Of course, not a very long thing. It's something you must hear. Very, very important. And very, very important. It's actually a question on binomial expansion, and it's something that I'm sure you have not, or except if you have done your research, you have not heard about it before. I saw it in the past question, and I think somebody sent the question to me also earlier, and I saw it was in the past question also. So you have to listen to that. It's very, very important. All right. Now, this next question we want to solve is also a direct question on harmonic sequence. It's a direct question on harmonic sequence. Now, this was the question. You had to find the fifth term of this harmonic sequence. The question said, find the fifth term. Of course, if you understand harmonic sequence very well, we did that in our class on sequences and series. So I'm sure if you attended the class, this should be easy peasy for you. But if you have not gotten your head around harmonic sequence, this could be a bit difficult because of the nature of the sequence. But I believe you should be able to solve it nonetheless. All right, this is the sequence: 2 over 9, 4 over 17, 1 over 4. Of course, it's a sequence that goes on and on and on. Very interesting question. I'm sure some of you may be with the idea of an harmonic sequence being that which has majorly 1 over something, like 1 over 2, 1 over 4, 1 over 6, and on and on and on. Well, I want you to have the proper understanding of harmonic sequence. You don't have to take it as something that looks like this. It doesn't have to look like this. Actually, this, what we have here, is an harmonic sequence. And you can see there is no 1 over as you may have thought. What is the proper definition of an harmonic sequence, and what must be your direction when solving harmonic sequence? When solving harmonic sequence, look at harmonic sequence as that sequence whose reciprocal, it's a sequence in which its reciprocal gives you an arithmetic progression. This is what will always help you to be able to solve an equation. Once you focus on this definition, you will never go wrong. Its reciprocal, that means the reciprocal of any harmonic sequence, must result back to an arithmetic progression. All right. Now, if that is being said, you are told to find the fifth term of this harmonic progression. So what I'm going to do is to go on to reciprocate all these terms, find the reciprocal of each of these respective terms. Of course, once I'm done doing that, then I can be assured that that will be an arithmetic progression. So let me try and find the reciprocal. Reciprocal is probably one of the easiest things in mathematics to do. What you have to do to find the reciprocal of something, you just make the switch over. So in this case, 2 over 9 becomes what? So the reciprocal of this sequence, the reciprocal will be 2 over 9 will become what? 9 over 2. 4 over 17 will become what? 17 over 4. 1 over 4 will become what? 4 over 1, and on and on and on. Now, because they told me this was an harmonic progression, harmonic sequence, I know already that this turns automatically to an AP, because they said this one was an harmonic sequence. So obviously this one has to be an AP by definition. So I've reciprocated this, and this is it right here. It turns automatically to an AP. So I'm very familiar with solving an AP, which I believe you also are. So by now, I can now go on to use my AP to get the fifth term. I will get the fifth term of the AP. Once I'm able to get the fifth term of the AP, of course, what I need to do next is to just reciprocate that back again, and I'll be getting the fifth term of the harmonic progression. Does it make sense? So I'm more familiar with AP. So what I have to do is reciprocate from harmonic sequence to an AP, of course, and then get my term, and then reciprocate back and get my term in the harmonic progression. So looking at what we have right here, of course, we have to first find the common difference. The common difference is quite very easy. Of course, I know my first term, but I need to find my common difference. How do you find the common difference? Of course, the common difference is always going to be U2 minus U1, and it must also be U3 minus U2. I need you to know that if it's a common difference, U2 minus U1 must be the same thing as U3 minus U2. All right, so what's our common difference there? U3 minus, this is 17 over 4 minus 9 over 2, while this one will be 4 over 1 minus 17 over 4. What does this give me? If you press this on a calculator, you should get a value of minus 1 over 4. And this also will give you minus 1 over 4, which validates our points that this is an AP, because you can see we have a common difference already. Now, what we need to do next is to remember our formula. We are asked to find a fifth term of this harmonic progression. So I need to go and find the fifth term of the AP. How do I find the fifth term of the AP? The fifth term of the AP, which is U5, will be A plus 4D. Of course, I'm sure you all agree with that. Now, this is on the basis of your AP. Now, this is my AP right here. This is my arithmetic progression right here. My first term is 9 over 2. And my common difference now, I've established it to be minus 1 over 4. That will be 4 times minus 1 over 4. Of course, please don't always see your difference, that your difference has to be positive. In this case, now you have a difference that gave you a negative value. So if I go on to solve this, of course, 4 we divide 4 here. So I'm left with minus 1. So my value of U5 will be 9 over 2 minus 1. And which will be what? What is 9 over 2 minus 1? 9 divided by 2 minus 1 gives me a value of 7 over 2. All right? 7 over 2. Now, notice that that is my fifth term when I was solving the AP. This is my fifth term when I was solving the AP. You see, if I'm going to give you a question on this particular, if I was the one that gave you this question, I can assure you that this will be option A. Because I want to test your ability to if you really understand what you're doing. So this will be option A, and then maybe option B will be something, and maybe option C will be something, and then option D will be the 2 over 7. Because I want to know if you really know what you're doing. Now, if you know what you're doing, you obviously understand that if this was the fifth term in an AP, when you are not told to find the fifth term of an AP, you're told to find the fifth term of an harmonic progression. So you have to go on to reciprocate this. And to reciprocate that, that will be 2 over 7. So that means the fifth term was going to be 2 over 7. So this is the fifth term of the harmonic sequence, the harmonic progression. This is the fifth term, 2 over 7. All right? So this is how you solve questions on harmonic sequence. Very, very simple and straightforward. So the last but not the least question we're going to answer in this particular tutorial is a very simple, quick one. But I want us to talk about it because it's very, very valid and very important. It came out in a particular question, and I understand that many of you may not even understand how to go about it. All right, this is the question that was asked. You were asked that the binomial series for 1 plus x raised to power n is valid only when, now I'll write all the options for you that was given, and then I would know, you would understand the option that is correct. So the binomial series for this particular expression 1 plus x raised to power n is valid only when, now this was the options that was given. This is question number 14 of a past question. Option A was x is less than 1. Option B, absolute value of x is less than 1. Option C, x is less than minus 1. Option D, n is less than 1. All right. So what are your options to this? What are you going to pick? What's going to be your answer to this if you were told to answer this? Can anybody give me an idea of it? What were you going to pick if you have this question? What are you going to pick if option B? Somebody said option B. All right. Option B, option D, option B. All right. Now, the correct answer for this question is option B. All right. The absolute value of x is less than 1. The absolute value of x is less than 1. Of course, I'm sure you understand that option B is that's actually what option B is saying, that the absolute value of x is less than 1. Now, this particular condition is quite very crucial. That means it's crucial for the absolute value of x to be less than 1, because you see, the binomial expansion for non-positive integer values of n it will result in an infinite series. Now, pay attention to this. If you have, look at what we have here, 1 plus x raised to power n. The binomial expansion for when you have a non-positive integer value of n. Look at when you have this n value, if you have a non-positive integer as your n value, of course, it will result in an infinite series. Now, that means if you have a remember what I said, if this n was a non-positive integer value, the binomial expansion always tends towards an infinite series. Now, for us to get this infinite series to converge to a finite meaningful value, that means for us to get the series moving towards a more finite meaningful value, the magnitude of the terms, of course, I'm sure you all know when I talk about terms, when you are expanding the terms, when you expand these terms, the magnitude of the terms must decrease, which will only happen if this condition is met, if the absolute value of x is less than 1. You see, if the absolute value of x is greater than 1, if it was greater than 1, the terms will not decrease sufficiently, and the sum will diverge. And in that case, you will not have your answer. You will not be able to get this. So it's very important that this happens. That means this value, the absolute value of this, is less than 1. This is like more like an expression for it. Imagine you have 1 plus minus 0.5 raised to power n, maybe a non-positive value of n. Now, this is nice. But if you go on to have values that are of this sort, for instance, 1 plus 5 or 1 plus minus 2 raised to power n, in these cases, these values, when you have a non-positive integer as your n value, these values, the term values will not decrease sufficiently. And when they don't decrease, it will diverge this particular expression. And for you to get a meaningful value, you always need it to be that the absolute value, of course, the absolute value will remove the minus sign, and the absolute value should always be less than 1. Once it's less than 1, then you are good to go. But once it's anything other than that, you tend to have, especially when you have a non-positive integer value of n, you tend to have a situation where the decrease will not happen sufficiently and the sum will diverge and will not equal to the expression you were given. All right, so I think I've answered that question. Sorry, I don't want to carry this question over. It's just a 2-second question. I don't know. Log x3. I just saw this question that I have right here. I know we are out of time. Probably just give me like 30 seconds. I want to exhaust this so that tomorrow will be a fresh start on a whole new set of questions. I don't want to carry this over to tomorrow. And of course, this will not take you more than 1 minute. So this was I just saw it right now and I don't want to carry it over. So we have log x3 plus log 9x is equals to 2. All right, can you solve this quickly and give me your answer? How do you solve this? I just want to be done with this. I don't want to carry this over to tomorrow. Log x, this will be log x3 times 9 equals to 2. This will be log x 27 equals to 2. Here we have x raised to power 2 is equals to 27. Then you are scared of what's happening here, but you don't need to be scared. Take the square root of both sides. This will be x equals to square root of 27. Square root of 27 is the same thing as square root of 9 times 3, which will be square root of 9 times square root of 3, which will be 3 square root of 3. All right. So that will be all for today. I just needed to exhaust the questions I had to solve. So tomorrow we start on a fresh start. And by 6 o'clock, are you guys voting on polynomials or binary operation? What's your final conclusion? Can I get a quick vote? Can you just drop your option? Then I'll use it to determine what we're going to do tomorrow. By 6 o'clock, don't forget that class will be by 6 for by 6 o'clock will be for any particular topic of your choice. And by 9 o'clock, we will always have past questions to solve. The main goal for the 9 o'clock classes is to get exposed to questions so that while you are learning a lot on these topics, you will be able to get exposed to lots and lots of questions. I hope that tomorrow we're going to solve many questions on function and mapping and some other questions. Obviously, there are many other things to solve. And I really hope that everybody present here, plus much more other people, are present, because the goal is for us to make these results remarkable. And I really believe you guys can do it. And I'm ready to give you the time and everything we need to achieve this result. So I think I see a lot of people choosing. Okay, I don't even know what to, because I can see binary operation, I can see polynomial. All right, it looks like, okay, somebody said we'll create a group, a poll about that. Okay, so, okay. Now, let me say this and let me be very clear. So if we don't do polynomials tomorrow, we'll do polynomials sometimes, probably on Sunday. But whatever the case is, probably you get back to me. No, the 6 o'clock, by the way, 6 o'clock is not for those who came late to the program. That's not what I said at all. 6 o'clock class is for everyone. It's actually for everyone. All right, it's for everyone. So you should all be present for it, especially because we'll be solving several more questions on all these things. All right, guys, I think it's been a beautiful moment. We'll be seeing by 6 o'clock tomorrow. I would love you to get back to me on what you will be loving to be taught tomorrow.